Good evening. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and today I'm going to give you a presentation on sustainability and supply chain management. Now, basically, when we talk about sustainability, a good definition of it, something real short, we're talking about going green. Let me give you some examples of going green. Recycling. We have switches that automatically turn on and off. They have sensors in them. That's to keep the lights out when you're not occupying a room. That actually saves money. Now, I know you hear the talk about electric cars. You also hear of taking trash and recycling that into electricity. And then we deal with the supply chain. The supply chain is what we utilize to get all of our goods and services. Now, when I talk about sustainability and supply chain or supply chain engineering or supply chain management, it's actually a branch of operations management. And matter of fact, I'm actually going to get into operations management with this topic. If you don't have the book, I would urge you all to get the book, the 12th edition. They also have the 13th edition out, Operations Management, Sustainability, and Supply Chain Management. And of course, this is by Jay Heidzer, Barry Render, Chuck Munson. Very good book, breaks down everything. And supply chain management is right under industrial engineering. In fact, Purdue University has its own major called supply chain engineering. All right, let's get into the topics. I'm going to talk about corporate social responsibility, sustainability, design and production for sustainability, regulations, and industry standards. And of course, our learning objectives. We're going to describe corporate social responsibility, sustainability. I'm going to explain the 3 R's for sustainability. I'm going to talk about calculating design for disassembly and explain the impact of sustainable regulations on operations. Now, when we deal with CSR, that's the acronym for it. CSR stands for corporate social responsibility. We're basically talking about how products and services affect people and the environment. We have stakeholders, and stakeholders have strong opinions about environmental, social, and ethical issues. Why? Because doing what's right can benefit all stakeholders. And all of that is under corporate social responsibility. Now, when we deal with sustainability, we're meeting the needs of the present without compromising the ability of future generations to meet their needs. I mentioned going green. It's a little bit more than going green. And who is included in that? Customers, employees, community, and of course, company reputation. Now, the systems view. Now, as you know, when we deal with the industrial engineering side, we're dealing with the system as a whole, optimization. Again, operations management, supply chain management, they're all under industrial engineering. So when we deal with systems view, we're basically looking at a product's life from design to disposal. And that includes all of the resources that are required to make up this product. Now, also, we're looking at the product or service itself, and that's basically a part of a much larger social, economic, and environmental system. It must understand systems to allow for more informed judgments regarding sustainability. Or commons. Well, many inputs into a production system held by the public. There are also common resources. They're often misallocated. So some of the possible solutions include moving some of the common to private property, allocation of rights, allocation of yield. Now, for sustainability, you may have heard this term TBL, which deals with the three P's. We call it the triple bottom line. And the triple bottom line, that is the system necessary to support the three P's. And the three P's are people, the planet, and profit. Now you see in this chart right here, improving the bottom line with sustainability. Has it right here. Minimize, and you have raw material, energy, water, and waste. You have the concept, design, raw material. Raw materials transported, manufactured, transported, consumed, and then it's transported for disposal. Then you have this chart. You have the planet, you have the people, and you have the profit. Put all of that together, that maximizes the triple bottom line. Also, when we deal with the triple bottom line, it's about the decisions that affect people. If you look at the market, everything is gone global. So we must understand globalization and outsourcing because the task is very complicated. And globalization and outsourcing complicate the task. And we have supplier selection and performance criteria. They're very important. And when we deal with materials, they must be safe and environmentally responsible. Now, one organization that I want to look at, let's look at Walmart's objectives. Now, Walmart's objectives are to improve the livelihoods through the creation of productive, healthy, and safe workplaces. Walmart wants to build strong communities through access to affordable and high quality services. They also want to prevent exposure to substances that are considered harmful or toxic. And Walmart also wants to promote health and wellness. Now, again, the triple bottom line, we're dealing with the planet's environment. We want to look for ways to reduce the environmental impact of operations. Now, what we have now is we have an overarching objective, and that's basically to conserve scarce resources. And then we have GHG, or golf, hotel golf, deal with the carbon footprint and the greenhouse gas emissions. Now we look at the carbon footprint. Now, right here in figure S5.2, the carbon footprint of a 34.5 gram bag of Frito-Lay chips. You start off with 75 grams of total carbon footprint. Then farming makes up 44%. Then manufacturing makes up 30%. Then you have 15% for packaging, 9% for shipping, and disposal, 2%. Now, it's how much gases are being emitted into the air. And if you add everything up, 44, 70, 44, 74, 74 and 15 is 89, and 9 is 98, and 2, that's your 100%. And this comes from a 34.5 gram bag of Frito-Lay chips. Now, we're still on the triple bottom line, and that's basically the social, environmental sustainability. They do not exist without economic sustainability. So staying in business requires making a profit. And we also deal with alternate measures of success include risk profile, intellectual property, employee morale, and company valuation. Then on top of that, we have social accounting, and that can supplement financial accounting to support economic sustainability. Now we have design and production for sustainability. Design and production for sustainability. So what we have here is an LCA. You're going to see that term a lot, which stands for life cycle assessment. And basically evaluates the environmental impact of the product, which goes from a raw source and energy inputs all the way to the disposal of the product at its end of life. So basically the goal is to make decisions to help reduce the environmental impact of a product for its entire life. This is where you come up with the 3 R's: reduce, reuse, and recycle. Product design. Now, design decisions affect materials, quality, cost, processes related to packaging and logistics, and how the product will be processed when discarded. Also, with product design, you have to incorporate systems view to lower environmental impact. We have to incorporate systems view to, we need an incorporate systems view just to lower environmental impact. And then after that, we need alternative materials. Design for disassembly. Now in this chart, we have a harmonizer. So the harmonizer is broken down into a part: a printed circuit board, a laminate back, coil, processor, frame, aluminum case, and of course total. So we have the columns: resale revenue per unit, recycling revenue per unit, processing cost per unit, and disposal cost per unit. And if you look at all the numbers, to get this number, you have to add these 3 numbers up to get this number. So if we want to resell this harmonizer per unit, the total is going to be $35.49. But you see what's included. There's a recycling cost, a processing cost, and a disposal cost per unit. Gives you this resale revenue per unit. Same thing goes for this rocker. We have the part, printed circuit board, coil, frame, processor, plastic case, and total. All the numbers are going to get you what you need here. Here's everything you need to know about the cost per unit of that product and the total. All right, dealing with a little bit of math here. Design for disassembly. You take your revenue retrial, which that equals your total resale revenue plus total recycling revenue minus total processing cost minus total disposal cost. And let me make a correction going back to this slide right here. This is these numbers that you see right here, and for the harmonizer and the rocker, you're going to see the same numbers on this formula. So you already have your charts for your rocker and your harmonizer. Now, let's get to the math. So your revenue retrieval, you have your total resale revenue, $35.49 plus $11.94. That's your total recycling revenue minus your total processing costs minus your disposal costs, and you come up with $22.13. That's your revenue retrieval. So basically, when you produce something, you're going to have some additional costs. Now, what are you going to have after the expenses? And this is how you look at business when it comes to expenses as well. You have your revenue retrieval for your rocker, $23 plus $12.75. And you subtract $18.39 minus 595 gets you 1141. Now, how did you come up with all these numbers? I'm going to show you. These numbers came up right here. 154, that's for your printed circuit board. 565, your processor. You add all these numbers up, you get 1194. Same thing in this column. Same thing in this column. Now, the production process basically reduces the amount of resources in the production process, your energy, water, and your environmental contamination. And with the production process, you're going to have reduced cost and, of course, environmental concerns. Now, getting into logistics. So we start to get into part of the supply chain. What we do with logistics, we're talking about reducing costs by achieving efficient route and delivery networks. So what do you want to do? You want to get your shipments to all of your clients or customers promptly. You want to keep trucks busy, but you want to buy inexpensive fuel. And when we deal with logistics, management analytics can help. You want to evaluate equipment alternatives, and you want to lower have lower life cycle ownership costs, or you want to deal with life cycle ownership costs. And when you deal with equipment, you must include salvage life. Okay, let's get into some real numbers here. Life cycle owner cost. So I have two examples, two vehicles. I have a Ford Tri-Van and a Honda City Van. Now, the cost to buy the Ford Tri-Van is $28,000. The Honda City Van is $32,000. Okay, when it comes to fuel, the Ford Tri-Van uses regular unleaded efficiency 24 miles to the gallon for about 20 cents. And that's a cost per mile. That's your operating cost. And your Honda City Van, regular unleaded and the battery, 37 miles per gallon. And that cost is operating at 22 cents a mile. So basically what we have here is your total life cycle cost that equals your cost of vehicle, which this is your cost of vehicle, plus your life cycle cost of fuel, plus your life cycle operating costs. So what we get is we take the cost of the vehicle, $28,000. Now we go back, your annual distance is 22,000 miles, your gas price is $4.25 a gallon, and your life is 8 years. So we have your cost of your vehicle. Then we have your annual miles traveled per year divided by your miles per gallon. Then we have your cost of your fuel, $4.25 per gallon, 8 years. Then we have 2,200 miles, 22,000 miles per year at operating cost of 20 cents per mile times 8 years. All those numbers together. And this is your life cycle ownership cost of $94,347. That's what we call engineering economics. And you have the same idea for the Honda City Van. Now, if you're looking at cost, which would be at a lower price to buy, this one would buy around $4,000. And we have your crossover point. This is when you're starting to compare. Your total cost per van equaling your total cost for city van. All the mathematics is figured out right here for you. So your crossover point equals 95,012 over 22,000 miles per year, almost 4.5 years. Now we get in the end of life phase. So what happens at the end of life? And we have closed loop supply chains or reverse logistics. And then we deal with the automaker's design, and that incorporates disassembly, recycle, and reuse. And moving on to regulation standards. Product design. We have the FDA, which is the Food and Drug Administration involved. We have the Consumer Product Safety Commission, they're involved, and the National Highway Safety Administration. We have manufacturing and assembly activities. One of the big ones, OSHA, the Occupational Safety and Health Administration. We have the EPA, the Environmental Protection Agency, and of course, state and local agencies. We also deal with the EPA when it comes to, and the DOT when it comes to disassembly and disposal of hazardous products. And then we also have design for disassembly. And of course, nearly all industries have regulations. I work in construction, but if you're on the commercial side of construction, commercial builders, then we have the Federal Safe Drinking Water Act, and then we have the Resource Conservation and Recovery Act. That's known as RCRA. And we have international environmental policies and standards. So we have organizations and government guiding businesses. The UN Framework Convention on Climate Change, that's UNFCCC. Then when it comes to international standards, we have the ISO. That is the International Organization for Standardization. And we also have the elimination of greenhouse gas. That's GHG. And there's the European Union emissions trading system. And what they want to do is combat climate change. They're going to reduce industrial GHG, that's greenhouse emissions, and have a cap and trade principle. We have ISO 400. And under ISO 400, there are the environmental management standards. And under the environmental management standards, there's environmental management, there's auditing, there's a performance evaluation, labeling, and of course, life cycle investment. Again, under the environmental management standards, we have environmental management, auditing, performance evaluation, labeling, and life cycle assessment. Now, the advantages are, and this is under ISO 14,000, positive public image, reduced liability, a good systematic approach to pollution prevention. Again, a good systematic approach to pollution prevention. And then we have compliance with regulatory requirements, opportunities for competitive advantage. And then we have a reduction in the need for multiple audits. Now, ISO 14,000 is implemented by more than 200,000 organizations in 155 countries. Again, the environmental and economic benefits: reduced materials, resource usage, reduced energy consumption. We want to lower distribution costs, improve image. We want to have an improved process efficiency, and we want to reduce waste and disposal costs. Again, ISO 14,001 addresses environmental management systems, also a guidance to minimize harmful effects on the environment. And again, there's a lot to learn when it comes to sustainability. But to break it all down, we're really dealing with green. You hear a lot of information on climate control. Now, there is also a lot of money when it comes to climate control. Now, I am for recycling. I work in the construction industry. And one thing that we do when we are paving new roads out here, well, we use a milling machine and we mill off all of the existing asphalt. It could be an inch, it could be 4 inches. Now, instead of disposing of all of the millings that come off the existing asphalt, you know what we do? Recycle. Come up with a product called RAP. That's recycled asphalt pavement. Now, plastic. We do a lot of recycling. Recycling is big. There's a company up in Northern Virginia called Cavanta. What they do is take trash and they actually make electricity out of it. Now, I'm going to say this about the climate. The climate is always going to change. What we have to do is basically reduce the greenhouse gases that are going into the air. Now, again, when it comes to the environment, you do have some individuals out here who are, I don't want to call them nuts. I just want to call them, they're emotionally involved in the government where they don't want any development at all. You know, they wanted to tear down the Hoover Dam because of a suckerfish, when all you have to do is redirect the suckerfish because you need the dam for hydroelectric power. And when it comes to the environment, there hasn't been any new plants built since 1976. And I'm talking about fuel plants. I mean, I live here in the state of Indiana, and a lot of our fuel comes from the BP plant in Whiting. Plants are over capacity. The capacity is that they're overloaded now. But when it comes to energy, certainly we're building a lot of programmable thermostats. We have sensors, electric cars. The problem with electric cars, the battery is way too expensive. So I'm not sold on electric cars yet. Now, there are other venues that someone could come up with to eliminate the combustible engine. And there are other venues to also help power, like solar power. And something else that you need to know, you really want natural heat when you build the house. In the winter, you want that natural heat. So you build it where the sun comes directly in your house on the east, and it comes directly in your house on the west. Solar panels can help, but if there's no sun, they're not going to do you any good. So you have a lot of methods out here that sound good, but do they really work? Problem is, they don't. They work sometimes. Now, in the green energy sector, you have buildings that are LEED, LEED. Those are energy efficient buildings. Now, we all want to be energy efficient because that cuts down on a lot of our bills. A lot of us don't know how to read our electric bills. So when we deal with sustainability and the supply chain, We want to optimize the supply chain where it's effective, where we can get products out for less. We want to make sure that when we design a product, we design it with some environmental concerns within that material. Because everything has a cost to it. And in the end, when it comes to the environment, when done right, a good environment is healthy. And that concludes this topic on sustainability and the supply chain management system. If you like what I just presented, please comment, share, and subscribe. And if you are looking for some political, social content, check out my main channel, the 411 Talk Zone Radio Show. Put a video up every Wednesday. Always go back and see my older videos. Now, if you cannot find the 411 Talk Zone Radio Show or the QCIS channel right here on YouTube, you can check both of those channels out on Twitter. And if you want to know something more of what I do with the QCIS channel, since this is more of an educational channel, you can find the same content that I post on Twitter from YouTube onto my Twitter page. And once again, I thank you for viewing this video on sustainability and the supply chain management system from the QCIS channel. On this channel, I give you a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.